Hi, I'm Gilvan Coelho. I am a big data engineer from LinkedIn, and today we're going to talk about the big data trends and how you can do the migration from our on-premise cluster to the cloud cluster, doing it it's the best way, and following that trends that we can discuss, and we're going to detail this in this presentation. So you have just talking about big data clusters. I'm gonna to just to tell something about Lambda architecture, just to deliver and to give some points that you can talk in that presentation. You're gonna to talk about the issues that you see happening in the big data clusters in on-premise or on the cloud. You're gonna to talk a little bit on that. I'm going to talk about the moving to the cloud. This is how you can focus and how you can do this in the best way to deliver the best way to handle the jobs that you have. You're going to talk about the data and processing. This is important concepts that in the cloud this working in somehow different than on-premise, and you talk about the service orchestration that you can have in the cloud. So let's start to talking about the Lambda architecture. It's the basic thing that probably you have been heard before. And you have in our architecture basically five layers in our Lambda architecture. The first one is data. It's about the data that is coming, can be bounded or unbounded data that give us, if bounded data, we're gonna have the best layer of the architecture that you're going to be working the kind of loads. You have unbounded data that you're going to be handled by the fast layer that you have in our Lambda architecture. And you have the serving layer that can give for the final users, for the end users, the SQL capabilities to do report, to join the data that come from each layer of the architecture, fast or best layer. And this is just a general looking about that Lambda. About that, all that layers you're gonna be talked in that presentation, and you're gonna to discuss about can we handle this in the on-premise and the cloud, okay? So, we're talking about the Hadoop ecosystem. This is the big data that we are talking. Here, you have some tools that are gonna be used. Of course, there are much more. The most common you're gonna be Hadoop itself, the ADFS, Hadoop File System layer, and you have Spark, and you have Yuzi, and you have Apache, and you have Pig. Everything is related to this big data architecture that you're gonna talk. So you are just talking about it in general way in that presentation. Tends to be agnostic, not to be related to the one cloud or one specific vendor. You're gonna talk in general way, but most of the functionalities that you're gonna talk, you'll be available in the big cloud providers that you have. When you are talking about the big data clusters, you have some issues that happen in on-premise traditional clusters implementation. The first one is when the cluster starts to work, when you start to migrate your job, you probably has a big cluster with a lot of availability of resource and disk space, processing and everything. And this, okay, you're gonna to start to move in your job, and in that moment you're gonna to have a lot of job in work, but a lot of resources being not used. This means that you are with something like a waste of money because you have a big infrastructure and you have some number of jobs that not using that infrastructure that you have. This is common in the on-premise or in the clusters implementation. It's how this working. So, and when you start to use your cluster, when you start to submit more jobs, and you are talking about the Spark jobs or Hive jobs or MapReduce jobs, you're gonna to start to process more data. You're gonna to carry on more data to your cluster. The clusters become full of processing, and you're gonna to start to have some trouble when you need to put a lot of jobs working together. This is bringing us to some lose of jobs, or the jobs are gonna to delay a lot, and you start to need to put more machine, and your cluster need to grow. And this is something that happen. So sometimes I have processing availability, but I need to put more data in my cluster. I need to move more data, but I have no disk availability, but I need to put more server inside that cluster as well. And the cluster is growing, and it becomes an issue because the administration has become complex. And this, I need more server because I need more data. I need more server sometimes because I need more processing time. And this is, our clusters is growing, the management, you're gonna be more complex. The purchase of servers to put on the cluster, this kind of stuff, is become more complex, and the people start to thinking to migrate to the cloud, because you're gonna be much more easy to put more resource inside that cluster. And this is how bring us to the next step, then how we can do that kind of stuff. Okay. So when you start to talk about the cloud migration, the first thing that you can think is to put your cluster inside that cloud. You're gonna be much easier to spin up new machines, and you will be much easier to grow the cluster. And this, of course, you're gonna help you to solve a lot of problems when you have an implementation on-premise. But you need to understand that going to the cloud, you have more advantages than you have on-premise. First of all, you need to understand how this happen. So database, the first of all database technologies, you have the big machines processing our load, and the data is bring to the processor. This big machine working that way. You have no horizontal scalability, but you have your load inside that one big machine that are processing your database. When you start to talking about Hadoop, to use Hadoop is distributed file system, and you have the processor data together in the servers, in the clusters, and when you move to the cloud have a capability that you can process your data inside where your data is. This means that you cannot need to move your data inside your processor machine. You can keep that thing separately. This is a big advantage when using cloud processing. This is bring us that going to the cloud, you need to separate the things. The storage, you're gonna be in one layer. The processor, you're gonna be in other layer. You have, for example, messaging in other layer. And this is you're gonna be put separately, and the cloud capability, the network with the high performance network, you're gonna help it to put that things together. And this, you bring our life much easier than you have a big cluster with all that things together. And this is how you can use the cloud to process that data. So the first concept is, in the cloud, I can put my data in the storage layer, and you can have the processing separately. This is the concept that we are talking about. So this is possible because that network, high performance network, can help us doing that. And this brings us for the other possibilities when we're talking about the clusters, the cloud processing. For example, I can spin up a cluster for execute some jobs, and I can isolate each job in a small cluster, and all that jobs you're gonna get the data inside the storage layer. So doing that, I can use a lot of small clusters to process my data, and I just go to spin up that process, that cluster, to connect that storage, processing that data, put the results that you want, and after then I can close that cluster, for example. This is one of way that I can do this kind of that. So I can use some tool like Airflow that can help us to put all that pipeline. Our pipeline is gonna be much more completed, because I need to spin up a cluster to connect that data. I do not need to move my data. I just need to connect that data, I'm going to process them, I'm going to save the results, and after then I can, for example, delete that cluster. If I have, for example, hourly cluster processing, I can do this hourly because we are talking about the jobs that you're gonna run in minutes or in half hour, for example, but I can stop them, I can save the results that I have. So this brings us to the concept that you can have a storage layer well defined, and you have the processing layer, and we are talking about Spark jobs, Hive, and so on. And you can do this in pieces. You can separate them, and you can grow, and you can avoid a lot of concurrence inside that kind of processing. And but I have more capabilities yet. For example, if I have a job that have been designed sometime, and now this job has more load, much more data than as expected, and I need to process that information, and I have a server configuration defined. And how can I do that? I have at the cloud, for example, capability to auto-scale on that cluster. And I can have Yarn, for example, metrics that can measure how this cluster is processing that data, and they can scale on that, and they can avoid, for example, that there are run of memory or have other problem that can stop that job to be processed. And the cloud, you can do this kind of stuff. So you can put the small clusters that I have to process my data, being auto-scaled, and it can be a good thing. So, and you have talking about the process of most of the jobs applied to the batch jobs. Remember that you have been talking about the Lambda architecture. You have a layer of batch, but you have a layer of speed layer that you need to process the data, that unbounded data, that data that's come and never stop. And you can ask me how I can put the server, for example, if I need to unbounded data that never ends, how can I close that job? So you have talked about the clusters that have been spin up, have processed something, and have been deleted, for example. And now we're going to talk about the speed layer. The speed layer is related to the unbounded data that is coming. The data is coming and never ends. And I need to have some, how can I say, structure to process that I can never be stopped. I have two ways to do that in the cloud. I can have a lot of services for serverless infrastructure that the cloud providers has available to process the kind of data. And this you're gonna be out in scale. You're gonna have no initial setup or minimal initial setup to do this kind of processing. Or if you choose to set up your servers, set up your infrastructure to process your unbounded data to speed layer, could be done as well. But you have a small clusters just to process that kind of job. So the last layer that you're going to talk about, it's just to make a connection with the Lambda architecture that we did at the beginning. You're gonna be the serving layer. The serving layer, as I have a layer with data well separated in the storage at the cloud, I can put some layer of engine of data to give the capability, for example, to has SQL queries or report tools or something that you're gonna to access that data. This serving layer could be something provided by the most of cloud providers has the serverless structure as a serving layer as well. And you can use in that to provide to read your data, to connecting your data, and providing the SQL capabilities to make reports and to make analysis or deliver the data to the data science team and so on. And this is the layer, the important layer that you have in our Lambda architecture. So just to summary everything, you have our cloud, you start to put the jobs, you have the jobs consuming a lot of resource, you have data and processing together, If I need more space, I need to put more machine. If I need more processing, I need to put more machine. And the things is become bigger, 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 and you start to think another solution. And one of that solutions is to migrate to cloud. The first way to migrate for cloud is about to replace the structure that you have on-premise, but doing that on the cloud with the same way, using a big cluster with a lot of machine. Of course, you're gonna be much easier to put more data, more machine inside that infrastructure, but you're gonna to have a big cluster and you're gonna be hard to manage. And so the best way to do that in the cloud is to separate the things, to put the storage layer, to put the processing layer, to have a small cluster to process your unbounded data to speed layer, and you can use the serving layer that you're gonna be provided by the cloud as well, looking for the serverless architecture and so on. And this brings us, as a data engineer, more capabilities, more understanding that you need to put in our jobs, something like as I need to spin up the cluster, and you need to delete the cluster by the end, and you can have a tool like Airflow, for example, that can do this kind of stuffs. And doing that, you have no more concurrence, you have no more issue related to the big clusters to be administrated, and you can have a small clusters that can process your data. Thank you for watching and spend your time to seeing the video. And if you have some questions, please contact me by LinkedIn. It's gonna be a pleasure to give you the answers that you need to clarify just the concepts that you are talking about. Okay, nice. See you.